Let's talk about the chemistry of carboxylic acids. First, we'll talk about how we prepare carboxylic acids. One way of preparing carboxylic acids is by oxidizing primary alcohols with strong oxidizing agents like shown over here. Another way of obtaining carboxylic acids is by adding acid into a cyanide. The cyanide group will oxidize into a carboxylic acid group, and the cyanide will also evolve ammonia as well, which is quite neat. If we were to take this cyanobenzene, where the alkyl group is a benzene ring, we will get benzoic acid as the carboxylic acid, which is a white precipitate, and ammonia will also keep on evolving. Another way of doing it is by oxidizing aldehydes with strong oxidizing agents, and it will have the same effect like oxidizing primary alcohols. We can also add Grignard's reagents into carbon dioxide, and we will get this compound. You see, because it acts like a double carbonyl group, and we can hydrolyze it to get we can hydrolyze this Grignard reagent to we can hydrolyze this compound to get a carboxylic acid, and we get this hideous son of a bitch as a byproduct. As we can see, like the MgCl, it attaches to this oxygen, while the R attaches to this carbon. We can also take primary or secondary alcohols, or in this case we have taken benzene as a 1R group, and we can oxidize it with strong oxidizing agents to obtain a carboxylic acid, in this case benzoic acid, which is a white precipitate. We can also obtain carboxylic acids by adding acidic water into acid halide, in which the halide group runs away with a H as HX, and the OH of water will take its place to form a carboxylic acid. Here we have an amide. We can react an amide with nitrous acid in HNO2, and we will get a carboxylic acid along with evolving nitrogen and water. And as we can see, we can see how like the carboxylic acid, the nitrogen and the water are formed. We can also add, instead of nitrous acid, we can just add, like add the amide into any acidic solution, and we will still get the carboxylic acid and ammonia. Now these are how we prepare carboxylic acids. Now let's talk about how carboxylic acids are used in reactions. Carboxylic acids turn blue litmus into red litmus. It can neutralize bases like sodium hydroxide to produce the salt and water. It can react with salts to produce the salt and hydrogen gas, and it can produce carbon dioxide from metal carbonates and bicarbonates. So it's a very strong acid. We can reduce carboxylic acids using reducing agents like lithium aluminum hydride dry ether water to form the respective alcohol. We can't do this with sodium borohydride methanol and water, because it's a weaker reducing agent, and it's too weak to reduce this into this. So we use lithium aluminum hydride dry ether water as our reducing agent for this purpose. We can also react carboxylic acids with an alcohol and under concentrated sulfuric acid medium, in which it will reversibly form an ester. We can also react a carboxylic acid with these reagents, which we have seen multiple times before, to form the respective acid halides. See, like here's a neat pathway of how we can convert a carboxylic acid into a into a amine, but we don't have to focus on that. It's a simple thing. Instead, I'll just end this presentation by just showing the reagents again. If you haven't seen any previous videos, we can use PCl5 delta, PCl3 delta, or SOCl2 delta to convert a carboxylic acid into an acid chloride. We can use PBr3 delta or HBr delta or red phosphorus Br2 liquid to turn the carboxylic acid into the acid bromide, or we can use Pi3 delta Hi or red phosphorus and iodine delta to convert the acid into an acid iodide. And this is the chemistry of carboxylic acids.